The idea behind a module, also known as a subroutine, term used in basic programming, basic not as an elementary, but as in the language basic, or visual basic probably. Also known as procedures, functions, that's what we call them in Python, methods, that's what you call them in Java, and C++ uses both functions and methods. The idea is that you bundle a block of code and you give it a name so that you can invoke it like that. And I think we did some programs where we drew, triangles and stuff like that. So we had a triangle function, a triangle module, so that we could draw a triangle just by calling, one word. And then we put some parentheses and maybe we pass some data in that controlled the triangle a little bit, But that's the idea behind a module. So you call the module by using its name to invoke the module, which causes it to execute. Why do you do that? So you can break your program down. If you're working on a large program with a team, you can say, okay, we're obviously going to need these modules. We're going to need some stuff that does some math. All right, Rebecca, I want you to do the math code. And, John, I want you to do the code where we read the data from the file. And, Abdul, I want you to do the code that writes the data back to the file. And so you kind of divvy it up. Okay, you're going to design the modules that do the input. You're going to do the modules that do the calculations. You're going to do the modules that do the output. And maybe one person, maybe one designer goes and, kind of specs that stuff out. Or maybe you get together as a team and spec those out. If you're working at IBM and you have 200 programmers working on it, obviously not everybody's going to contribute to the design. You may just be given, the specifications and write to it. But anyways, you can break it up. Get 3 people working on that problem rather than 1. It's easier to test that way. Even if the rest of the code is not done, I could test the math functions. I could write a little test script. I could give those math functions the right input, and I could see if they get, the right output. That kind of thing. So, modules break down the large program into short things. It's kind of like the outline of a paper. If you're writing a term paper and you have an outline, imagine that outline is actually module calls. And then you go and you do the intro, and then you come back, and then you do, point 1, you come back, and you do point 2, come back, and then you do the summary, point back. Same idea, you make a big concept in your head, you break it out into smaller tasks, and those smaller tasks can be modules. When do you use modules? For one thing, if you wind up cutting and pasting code. If you're copying and pasting code, you know that you should have put that code in a module. Copying and pasting code is the devil. You shouldn't do that, because if you put that code like more than twice in there, you can be sure that later on you're going to need to modify that code, and you'll probably put the fix only in one place rather than twice. But if you put it in a module, you only have to make that fix once. That's one reason to do it. Another is that it makes it easy to share the code. Back in the old days of Windows programming, just to write like Windows 3.1 I'm talking about, just to write a program that would display, a window with some text in it and a button, would take hundreds of lines of code. And you would buy, Petzold's Guide to Windows Programming, and it'd show you how to do that. But then Microsoft came up with modules you use. Okay, here's how you make a window with just a few lines of code. That's a very good thing. It's a standard library. But you can design things like that yourself. If you find yourself writing a program and you find yourself, doing the same sort of thing over and over and over, just take that code, put it in a module, and then you can import it and use it over and over. The Turtle library is a module, for example. Actually, it's a collection of modules. So that way, if you were going to draw a picture on the screen, you wouldn't have to research how to do all that. You just use the existing library. So that's kind of the strength of libraries. Libraries are just collections of modules. You can make your own libraries. That's known as functional decomposition. I don't know why decomposing. Yeah. I'd need to look up, the Webster's definition of decomposition to understand why decomposing can mean, a body decaying and also breaking something down into modules. I guess it's that breaking down idea. It gives you the ability to do abstraction. Abstraction means pay attention to the large concepts and then focus later on the small details. Or you can ignore the small details, make somebody else go through the small details if you agree with what the modules are supposed to do. So you pay attention to the important properties while ignoring, for now, the non-essential details. Or you get a library from somebody and you never need to know the details. I don't know how the Turtle library works. That's known as selective ignorance. Ignorance sounds like a bad thing. It's a good thing. If you can do something without knowing everything about it, you can get it done much faster. Yeah, you need to know how to learn stuff, You have to have a good background in it, but programming is such a large task. You know, it would be like if you were a surgeon, you had to know how to operate on every breed and species of animal on the entire planet before you go to, work on a human. That's not the way it works. Fortunately, compared to physiology, a lot of organs are the same, so you just have to learn, one particular topic and know that there are other bodies of knowledge, and then you go see a specialist if you need to, learn about a specific thing, if you're a nose and throat guy, or, somebody who's going to treat your, your rare viral disease or something like that. So modules provide a way to achieve abstraction. Abstraction is the ability to just understand the large parts, and then the more complex stuff is hidden behind a layer. You may write that small stuff too, but then you can reuse that stuff. You can bring it in other programs, and boom, you're doing it instantly. I already mentioned that. Multiple programmers work on a project. It's how software teams work. Reuse your code. If you write a function that asks somebody for a number and it checks to make sure it really is a number rather than crash because they typed in a bad number, you could write that as a module, and then you wouldn't have to rewrite that code or copy and paste every time you wanted to use it. Now, if you get ambitious and start doing stuff like that, I ought to give you extra credit for it, but you better give me that module. You better upload everything, that makes your program work, because if you only gave me one file and it relies on other modules that you've written, I can't get it to run. So you'd have to give me the modules as well. So reliability, you can test each module separately to make sure that it works. So modularizing a program. Basically, you'll have a main program, and then you'll have modules, and the main program invokes that module. The main program is the stuff between the start and the stop in your pseudocode. And then there'll be modules. Modules are also pseudocoded the same way, but they don't begin with the word start and stop. Instead, they begin with the word, the module name, and they end with the word return. Naming your module just follows the same rules as a variable. There are rules for naming variables we talked about. Can you put a space in a variable name? Can you say first space name is equal to Joe? Have we talked about these rules? I see people not looking at me, and that's hurting my feelings. Okay, so rules for naming a variable. Can you start a variable name with a number? Can you call a variable 1987 tax rate? Yeah. That's a big no. Let's do the list of the variable rules. They're short. I'm actually going to change this to officially identifiers. That's what they're called. And why that? Because the same rules apply to module names. Letters, numbers, underscores. Some languages let you have a couple of other symbols, like dollar signs and stuff like that, but these are the only ones you can guarantee being supported by just about every programming language you're going to ever hit. In many languages, it cannot start with a number. No spaces. Now, the letters cannot just only be English letters. Some programming languages, the variable names might be in Russian or something like that. But, whatever. It's still a letter, right? It's just not a letter in the language that we're familiar with. Now, in a way, no spaces kind of is included in that one, right? Because if these are the things that are allowed, then that's definitely not allowed. But I go ahead and I break it out as a separate rule. I guess I could. I'm going to leave it down there. Yeah. No, I'm not. The programmer in me wants this to be absolutely correct and just lists that as a subscript to that one. Okay, so those are the rules for naming modules. Those are the rules for naming variable names. So 1, 2, 3, or 2007 and 8 tax return, bad variable name. Tax return 2017, good variable name. Tax space return 2017, bad. Tax underscore return 2017, Good. TR, it's legal, but bad. Why is that? Because a programmer looking at your code wouldn't know what TR means. Even worse are one-letter variable names. What if you just made it T? Okay, great. So while you're trying to figure out in somebody's program what the T variable means, you do Control F and you search for T, right? It's going to show every T. And yeah, maybe the editor will let you say, okay, words only or something like that, but it's really not a good thing to have single-letter variable names. The only exception is for counters. If you're going to write a loop that counts I from 1 to 10 or something like that, go ahead and call it I and don't give it a complex name like iterator or something like that. Variable names should be descriptive. I'm actually going to make this a rule. We're going to move that up there. If you've abbreviated it so much that somebody else looking at it couldn't figure out pretty quickly what it meant, you made it too short. On the other hand, do you need to make it, a book length, 20 words in it? Tax return 2017 as calculated for, Massachusetts. What? Yeah, that's a bit much. You don't need to do that. Pick a happy medium where the variable name is understandable and easily searchable if you did Control F, but not so much that every time you typed it, you had errors. Not too short, not too long. There are multiple styles for naming your variables. And what do I mean by styles? The book covers like 4 of them, but really I'm just going to break down 2 of them. You could do tax underscore return, or you could do tax return like that, separating the 2 by an R. Now when I'm up here typing code, I would rather use underscores than capital R's. Why? Just because when I'm walking around, half the time people will have made a lowercase r there, rather than an uppercase R, half the time, in parts of their code. So when I'm typing code up here, I don't always illustrate the way I would do it if I was a professional programmer. If I was writing Java code, this is the preferred way of doing it nowadays. That's the way all the cool kids do it. That's the way that all the professionals do it, because the people who invented the Java language recommended at the beginning it just stuck. Earlier, like in C++ and in the 80s and the 70s, people did that with the underscores. So I kind of like the underscores. I think that that's a little bit easier for me to read. But either's totally good. Also, tax return is okay too. It's just that these are supposedly a little bit easier to read. All of these are good styles. My option. Alrighty. I never make fun of anybody else for making typos, because as you watch me, you'll see me make plenty of them. Alrighty. So modules, I'm not going to type a lot of notes about modules. Read the PowerPoint. To sum up, block of code. So you can activate that code, you can execute that code, such a violent term, with a single word. Break your program down into modules. Now at this point of the game, I'm not going to say you have to do that. Man, I have to break every program down. No, if it's a simple task like that conversion stuff, enter the number of miles and turn in the number of feet, you don't need to break that down into modules. But you can. I'm going to do a conversion program. Well, not quite a conversion program, but I'm going to do a program that's about that easy, but I am going to break it down into modules just for illustrate. If I say the program needs to be broken down into modules, then yeah, you won't get full credit if you don't. But we're not there yet. Teams of programmers can work on the modules. Modules can be tested separately. Modules make for good code. Modules can be reused. These are advantages of them. Eliminate duplicate code. Duplicate code's always a problem because then if you have to make a change, what if the tax rate changes and you didn't put it into a module? Then if you had to change that 30 times in the code, you might only change it 29 times, and then you'd give the wrong answer sometimes. That kind of stuff is serious business. I may have given you this example already, but a multi-million dollar NASA rocket, to Mars, slammed into the planet. And yeah, that stuff happens. For a while, Russia was, also sending probes to Mars, and a lot of theirs failed. Most of the American ones have succeeded, but this one just slammed into the planet. It did everything perfectly, and then, it turned towards the planet and, accelerated into it. Not what it was supposed to do. The reason why is that it was programmed. One of the modules had been programmed so that it expected metric units, this many meters, this many kilograms, per, second of thrust and that kind of stuff. But the data it was given, that it was programmed in, was English units, miles, and, stuff like that. Obviously, that's a very bad thing. So what they did is they didn't test their code adequately. They didn't check the specifications of their modules. Oh, this one is expecting metric data, and this one is outputting English data. So that's why you want to test your modules. In a large programming division, you'll have people whose entire job is to test. Sounds boring, but it's not really. It's a game. The programmers write something, you're trying to break it. Kind of fun. You build up a little competition, and then they slowly begin to hate you. So anyways, testing is your idea with the idea of video game. You all have the idea of video game testers. People that are hired by video game companies, and their primary job is to sit there and play the game and try to find bugs in it. Nowadays, video game companies consider their mass audience, their testers. They'll just blast it out, on the Sony network or Xbox or whatever, and then they'll wait until, millions of people start reporting bugs, and then they'll, modify it, whatever. That's called beta testing. Beta testing is when you give it to a customer and they find problems, and then they, usually, that person is supposed to know that they're getting beta code. Alpha testing, I guess, would be the testing that's done in, in company before it's shipped. Alrighty, I guess that's eliminate duplicate code, allows abstraction, breaking down a problem into smaller bits. Okay. I could conceivably ask on an exam, name 3 benefits for, using modules in your code. I list 6, that wouldn't be too hard, especially if you took notes or, whatever, because in my exams I allow you to view anything that we've uploaded into D2L, including the daily, notes, and also I allow you to bring your own notes. So, if you write hand notes or you type stuff in, that's great. All right, so let's write a program that has modules. I'm going to pseudocode it in idle, but then I'm going to comment it out. Just because pseudocode will not actually run, and I want this to be running code. So I'm going to do a file new. Here's what I'm going to, if you're already used to that idea, right? These make little comments that are ignored when the code runs. You can make a whole bunch of lines. It's called a multi-line comment if you open it with 3 quotes, 3 apostrophes. It can also be 3 double quotes, like that. So I'm going to just type those 2 things up there. And here's my task. Ask the user for the radius of a circle and display the area and circumference of that circle. Now, if I was going to go easy on you, I would give you the formulas. I could be within my rights to tell you to look them up, and then if you got stuck on them, text me and I'd give them to you. Not a math class. So the formulas we could use is that the circumference, which I'm just going to call it circum, because the longer we make the word, the more typos there are, is equal to 2 times pi times r, radius. And then the area is equal to pi times r squared. So that's our task. So pseudocode for it. Start. Input, radius. Why am I not just using r? Because it's too short. And then circumference is equal to 2 times pi times r. No, not r, radius. Area is equal to pi times r to the power of 2. And then output radius. That's the pseudocode for that. I'm not going to go and draw a flow chart for that right now. And then stop. Now I would give myself not 100% on this because I didn't tab this stuff over. That's only worth a 95%. Okay, so there we go. That is valid pseudocode. We could fluff it out a little bit by putting the output statements as well, right? Print, inner radius, that kind of thing. But this is the bare minimum. So after my triple quotes here, I'm going to actually start writing the program. Now remember, if you're going to input a number, we need more than one step in Python. What are the 3 things you have to do? You have to give some output telling the user what to do, because if you have an input statement and you haven't printed any text, or you don't put anything inside the input statement that produces text, it's just going to be a blank screen. The user's not going to know what to type. So we would need some kind of print, or at least put something inside the parentheses of the input statement telling the user what they need to type. And then once we get that number back, we have to convert it. So it's a 3-step process. Display the query, the question that you're asking the user, do the input, and then do the conversion. So in Python, we have those 3 steps, where the pseudocode only has 1. So let's do that. I'm going to go ahead and put the start here, but instead I'm going to call it main. This is going to be our main code. So let's print a message, or at the least, put that text inside the input statement. Radius is equal to input, parentheses, what is the radius of the circle? I could have put that in a print statement above it, right? I could have said print, what is the radius of the circle? And then when I called the input function, I would have just left off the text between the parentheses. But, saves me a little bit of typing if I put it in one line. So I may as well do that. Now I have to convert it. Radius is equal to float radius. Because you can't do math on a string. String is one of the 3 main data types. What are the other 2 main data types that we've talked about? There are 2 numeric ones. I know somebody was awake that day.
Programming?
Yeah.
And objective. I'm sorry, process.
You're going in a too complex direction. If we have 2, which is cool, but if we have 2 types of numbers that we're tracking in a program, what are they?
It's float and string.
Yeah, floats and ints. What are floats? Those are numbers that have decimal points. Ints are numbers that don't have decimal points, and strings are things between quotes that might have numbers, but they might also have words. So you can't treat them as numeric data. And that's what input returns. The user might type in 12, but they might also type in Fred if they're trying to break your program. And so if that was the case, then this line would fail. And when we become more skilled programmers, we would write code that we detect that failure had occurred and accommodated for it. But right now, our program's just going to crash. And since we're just starting out, that's fine. Okay, so I'm going to go back to my notes over here and add that. We have 3 data types so far. We've also used a 4th data type, turtle. Turtle is a data type. It's a data type provided by that module, but it's a very complex one, right? Because it's got lots of subunits of data. It's got an X and a Y position on the screen. It's got what direction it's going. It's got a color. It's got the pin thickness, which I don't think we changed. Maybe we did. It's got the speed. So, right, that one turtle's got a whole bunch of components. That's called an object. An object is a variable that's got more than one piece of data stored inside it. But the ones that are built in are string, ints, and floats. Strings are stuff that are inside quotes. Ints are whole numbers. Floats are, you know, what is it called in math terms? Real numbers or something like that? I don't know. Yeah, so we're just going to say numbers with decimal points. Now, fortunately, in this language, we don't have to make a big distinction between ints and floats. We can kind of use floats most of the time without any side effects. So for my demonstrations, I just turn things into floats because it'd be nice to let the user type in a radius of 2.5 and not have it crash because they just typed in 2. So every variable has 4 components, but I usually don't mention the 4th one. The book mentions it, though. So I guess I'm going to go ahead and say 4. They have a name, the identifier. They have a type, which is the data type. Example, string, int, or float. They have a value, and then they have a memory address where that value is stored. Now, in this language and in a lot of languages, you can't tell what the memory address is. It manages that for you. If you're using a slightly more, I won't say complicated, something like C or C++, which is an older language. You know, the original programmers, they didn't even have variables. They had to do everything by memory addresses. And if you remember back to my early lectures where I was showing, you know, the guy in the box reading from memory, all he knew is I'm going to read from 3 and I'm going to write to 5. Much better if you can get those memory, you know, addresses names. So really, I want you to remember those 3. If I ask for 3 components of a variable, be able to name 3 of them, I prefer you to say the first 3. If a variable didn't have a name, you wouldn't be able to use it. If it didn't have a type, the program wouldn't be able to use it. Why? Because operations. Operations are things like addition or multiplication or any manipulation of that data. Numbers support different operations than strings. You can divide 2 numbers, right? You can say 12 divided by 3. Yeah, that's cool. So numbers support the division operation. Strings do not. If you say Jeff divided by Thompson, how's it supposed to calculate that? That doesn't mean a darn thing. So strings don't support a lot of the mathematical operators. They do support the plus sign, though. That just appends 2 strings together. If you say Jeff plus Thompson, you get the resulting string, Jeff Thompson. Didn't do math on it, but it so-called concatenated them together. Concatenating is adding 2 bits of text or multiple bits of text. Okay, so going back to our code, because I really would like to finish this one today. We've done the first part. We've done the input. Now we're going to do our calculations. I'm going to put a little comment here. Get input. Now I'm going to do another one. Calculate. I almost wish I hadn't put these comments here. I'm going to leave them though. But when I write this as a module, they're going to wind up looking a little bit different because I'm going to combine 2 of these sections into one code. All right, so the calculations. The area of a circle is equal to pi r squared. Now, we've got a problem. We've never defined pi. Pi is what's known as a constant. It's not ever going to change, right? Everywhere in this universe, pi ought to be the same value because the circle doesn't change in our universe. Maybe if you go to some alternate dimension, whatever, you know. So constants, in some languages, you define with a special keyword that says the program cannot change this in the code, right? Once it's defined in the code, it stays that value throughout the entire body of code. In this language, there is no keyword, so you indicate that it's a constant with uppercase letters. And why do you do that? So if another programmer comes in, they won't try to change its value. Oh, well, I like PI. I'm going to use it for the name of the private investigator, and I'm going to say PI is equal to Jeff, you know, whatever. No. If you see something that's defined in uppercase letters, it means that you're not supposed to use that for your own purposes. You're not supposed to give it a new value, so it's called a constant. So I'm going to put another comment up here called declarations. And in my declarations, I'm going to give a value for pi, 3.14159. Good enough. Now we could get the value of pi from a library. There's a math library that's got pi, you know, declared out to 20 or 30 digits. If you were doing engineering work, you know, 5 places of precision would not be enough. If I didn't do that, this line of code would fail because it would hit that and say, I don't know what pi is. You have to declare every variable before you can use it. The book shows putting declarations in its own block. I honestly should have done that in the pseudocode. I forgot. It also goes in a block in the flowchart, which when we get around to flowcharting this stuff, we will show. Just hoping to do the modularization today. All right, so we've done our calculation, but we had 2 of them. Circumference is equal to pi 2 times pi times radius. I could have written a pi times radius times 2, but that looks so much like pi times radius squared that I preferred to rewrite it. All right, now we're going to do our output. Print, parentheses, quote. You could just use the single words, area is, or you could write out the whole sentence. You know, if you're a fast typer, write out the whole sentence. If you're not, then shorten it. The area of the circle, because the words of the circle are kind of superfluous. The area of the circle is, end quote, comma, area, in parentheses. And then print. The circumference, I don't care if you spell it right, you know, user would, of the circle is, end quote, comma, circum. Why did I use circum there rather than the whole word circumference? Because that's a variable name. If I wanted to use the whole word circumference there as a variable name, I better use it everywhere I reference it in the code. You know, variable names are just for your purpose. You know, you could call this Tony Stark. Don't make this change. As long as you call it Tony Stark down here, the program would work just as well. Are you going to give silly, cute names like that? Probably not. Okay. So our program is done at that point. I kind of like printing a done message at the end. So I'm going to tack that on. And what I'm going to do next is I'm going to test my program, make sure it works, and then I'm going to wander around and make sure that y'all's programs work before we go into the next step. So I hadn't saved it yet, which is a bad idea. I should save it, you know, every like 5 lines of code I type so I don't lose a bunch of stuff. February 27.py. Some programming languages don't allow file names to have spaces in them. Python's not so picky, but I'm going to start taking the spaces out. All right. Gotta run it. What is the radius of the circle? 10. Okay. I was lucky enough to not have any syntax errors. So if I type in 10 as the radius, the area is 314, and the circumference is about 63. Hopefully yours will produce about the same results. So I'm going to wander around, make sure everybody's got it going. So invariably the problems are typos, things like spelling radius like that in one place and not the other. And as many typos as I make, I totally understand that. The other is not using the triple quotes in one place or the other. Or if you're in the back of the room and you couldn't tell there were quotes and you thought they were asterisks or something like that. So, good job, y'all. And let's break it into modules now. Ideally, I would want to break this into 3 modules because there's 3 sections. But honestly, for this case, I'm just going to break it into 2. I think 2 is enough. I want a module called input, and then another one that does this stuff. So what I'm going to do is I would kind of like to leave this code, right? This is good code. So I'm going to do a save as and then make all my changes to my new version of the code. That way I can always go back to the original. So do file save as and give it another file name, even if it's just feb27b, right? Or feb27 modularized, you know, something like that. Give it a different name. Now we're going to make some changes to it. In this language, the way you define modules is with the keyword def. Bet you remember that from our turtles. So I'm going to do def get underscore circle underscore data. I know that's longer than I usually make y'all type, but you can handle it. Everything that's part of the module needs to then be indented because that's how it knows it's part of the module. You've probably seen other languages that use curly braces to mark the beginning and end of modules, but this one doesn't. It uses tabs. And that gets annoying if you've used, you know, don't tab everything just perfect. It doesn't work. Okay. That's my first module. Now this keyword return. Why am I putting a return? Because we need to get the radius back out of this code. I could leave this word off, this line off, and then demonstrate the problem. I think I'm just going to make it work this time, right? Rather than use it as an object lesson, make a mistake, then make everybody correct it. Okay. So what this means is after you do this calculation, this variable needs to be able to be accessed somewhere else. Any variable that's defined as part of a module is only accessible in that module unless you use a return statement. So if I put print radius down here and I didn't have that line return radius, it wouldn't work because this variable is only available in that module. That's called the scope or the range of the variable. So anyways, take that out. All right, this module is going to be called display results. And again, I have to tab everything underneath it. You can always tab by highlighting multiple lines, or you can just do them one at a time. Now this one doesn't really need a return statement because it's not returning any values. Yeah, we could return the area and the circumference, but we're not going to use them anywhere else in this program. So I'm not going to return any values. I'm just going to stick the word return, but it's not returning anything. That just marks the end of the module. This word main up here is kind of in the wrong place. I'm going to delete that line, that comment that says main. I'm also going to take a space out there that you don't have to do. Okay. Now, great. I've made my code modularized. I'm going to run it. Doesn't do anything. Why? Because I never actually invoke. I never actually call the modules. It's like you printed out a map to go to Walmart, but you never actually picked up and used the map. The map doesn't do any good. So we've defined some modules, but we haven't called them. So what we're going to do is radius is equal to get underscore circle underscore data, parentheses in parentheses. Now I've made an error in my display results code. Not intentionally. I just forgot to do something, so we'll fix it in just a minute. And then display results, parentheses in parentheses. Okay. This code's got a bug. It might not even run. I think I proved that it would run, but in other languages it wouldn't have run. The problem is that inside display results, we're using a variable that's never been defined, right? Nowhere in here, nowhere up there do we have a value for radius. We've got a value for pi, so it can do that part, but it can't do that part. So we have to pass in a radius. We have to define a radius parameter there so that we could pass it in. So I'm going to change this line right here, and so I'm going to try to make a big comment to make it easy to note that I changed this. Do you have to do that? No. But that's the line that I'm changing. Display results. I'm going to stick the word radius there. But that means I have to change this one as well. Because if there's something between the parentheses here, there has to be something in between the parentheses there as well. And at this point, I'm not making y'all. I mean, I won't. Yeah. I'm not going to make you write your own code yet that accepts arguments. But pretty quickly, y'all are going to be exposed to that. So anyways, I had to change that line as well. So I'm going to flag that with a big comment as well, which again, you don't need to make. There we go. Hopefully, if I ran the code, it'd work. Go ahead and try it. Beat me to the punch. See if it works. Wave your hand if it works. If it didn't, then I made a mistake. All right, I'm getting some hands. So, excellent. Let me run it and test it myself just to make sure. Radius of the circle, 10. I get the same results, so it still works. The code is more modularized, meaning that if I wanted to do something different with the output, like I wanted to display it in a nice graphical user interface window with an OK button, I would change the output code only. I'd be able to, send John to do that. Or if we wanted to be able to get the circle data in a more reliable fashion so it wouldn't crash, you could run your program and type in something that was bad data, like it had letters in it as well as numbers. Your program's going to crash. That wouldn't necessarily be a good thing. We could tell, Susan to go and fix the get circle data to be more error-proof. So you could, again, have teams of people working on this code, and you could test each one individually. All right, let me wander around, make sure y'all are all up and cooking. If you didn't put the pseudocode up at the top, then just watch and learn. If you did, great. I'm going to take these little comments out here. All right, so I go back up here, and this was my pseudocode, but now it has modules in it. It has two modules. Remind me of the names. Oh yeah, get circle data. So I'm going to do, I like going ahead and using the word DEF. The book's not going to show that, unfortunately, so if you do it the book way as well, that's fine. Define get circle data, parentheses in parentheses. It's starting to look like Python. And then input radius, and then return radius. That's all the pseudocode for that has to do. Then we had another module called output results, I think. Display results, excuse me. So I'm going to, the book shows putting the return statement unindented like that. I wouldn't care if you indented it. Define display results. Remember, the book likes to put the word set in front of the calculations, and I forgot to do that. I'm never going to count you off for doing it either word. You know what? I could just be copying this code from down here. Make it easier to type. Set circumference equal to 2 times pi times r. And then set area equals pi times r squared. And then print for output, I don't care which word you use, output circumference, output area, return. And then now our main code is going to be a little bit different. Inside the start and the stop block, it's going to say radius equals get underscore circle data, parentheses in parentheses, and then display results, display underscore results. Now I made a mistake, same mistake I made when programming it. I forgot to pass something in here. I really ought to go ahead and do that to make it correct. But if you turned in code where that was left off, I'd give you majority credit. I need to put the parameter there and the argument that fills in the parameter here. Okay, so great. We just blew up 6 lines of pseudocode to like 20 or something. Yeah. Sorry about that. But it actually does make for a better program. Because later on, you could reuse this code somewhere else. You could test the modules separately. Sometimes you don't see the reason for doing stuff the first time you do it. That looks a lot more like a programming language, actually, than merely pseudocode. According to the book's rules, my display results module has a problem. Anybody spot it? It's okay if you don't, but it'd be cool if somebody spotted it. Compare it to the module above it. It involves indentation.
Return.
Yeah, I should have unindented return according to their rules. The reason I don't like that rule is down in the Python code, return did have to be indented. But pseudocode is not a programming language. Alright, so that's our pseudocode. If you scrolled up and down and compared it to our Python code, you'd see that it looked pretty similar, but it is simplified slightly. The only module that's really simplified is that one. Then we could flowchart it. We could flowchart it. We would have 3 chunks of code. We'd have one column, which is the main code. We'd have another column for get circle data, and we'd have a third column for display results. We don't have quite enough time for that, so we're going to go ahead and end class a little bit early so that people who are stuck on the homework and need to ask questions get the chance to do that. Are we all good? Does anybody want to print out of this because you got behind on the typing? Print out? Okay. I need to type faster. Everybody's keeping up. I need to make it challenging. I'm kidding. Alrighty. Let's make a Dropbox for it. Oh, there's a homework assignment that goes with this. I need to mention the homework assignment. Be negligent if I didn't. Let me make the Dropbox first so that people can... Anyways. Alright, if you refresh your Dropbox, there's an in class E. Now, you probably actually made 2 PY scripts if you did the save as thing, so just go ahead and put both of them there. If you only made one, then that's fine. So our homework is to edit this program. If you absolutely can't get the program to run, at least make as many changes as you can. We're still not quite to the point yet where I'm going to give you a failure because you couldn't get your Python program to run. But I'd like for you to get it to run. You'd feel better about yourself. You could, brag to your spouse or kids or whatever, your significant other, hey, I made a program. So anyways, here's the assignment. Take the program code on the second page, which is just a similar version of what we did here, except it has different module names. You can also use your own code, the one you just did. The only difference here is the name of the modules. Take that code and change it to be a program about spheres. Modify it to print out the volume and surface area of a sphere rather than the area and the circumference. So the code for the program, if you don't have your word from February 27, is on the next page. Make the following changes. Since we're dealing with spheres, change the word circle everywhere in your code to sphere, right? And then change the module. The area calculation needs to be changed because the surface area of a sphere is calculated differently than the area of a circle. So I give you the equation here. It's just 4 pi r cubed. And then the volume of it. We're not actually calculating the volume right there, so that's going to be a brand new calculation and a brand new print statement. Volume is equal to 4/3 pi r squared. So that's our program. That's our assignment. Does that make sense? Just take your work that you've done, change the words circle to sphere, change the calculation of area, and then add a new calculation and a new print statement to handle volume. Go ahead and do that in Python if you can. You could just do the pseudocode. I'd rather you do it in Python. We saw that the code was almost one-to-one with the pseudocode by the time we redid it. That makes sense?
Are those instructions going to be too early?
They will be
Okay.
very, very soon. Let's do roll and call ourselves done.